What's the coordinates? All right, waves and sound. So by the end of this lesson, you'll be able to describe, identify parts of the wave, calculate the speed of the wave, identify different types of waves. So we are talking about waves. So let's kick it off with one. Ready? Come on, get it! Woo! Yeah! Woo! Yeah! Come on! Yeah! 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 Woo! Woo! You guys redeemed the last hour. Last hour was like I've never honestly being completely sincere. I was completely dead. Like nobody. I did it 4 times, and they're like, "What's he doing?" I did. I was like, I took 3 times. I was like,
they weren't awake.
no, you guys did awesome. Like if it feels better. I was taking a little bit personally. Like, what's the old ball guy doing? Like, he was just.
Can we do it again?
We just did it. It was good. It was good. I liked it. All right. So. Traveling disturbance through medium. That carries energy. Traveling disturbance through medium that carries energy. Okay. So it's never helpful when you define something with words that you need to define. Thank you. So medium. What is medium? Well, it's not too big. It's not too small. It's just medium. No.
It's like the thing goes through.
Yep. This is the medium. Medium is the material through which a wave travels. Okay? The medium is the material through which the wave travels. Okay? In the case of what we just did here, the wave in class, what was the medium? You. Okay? And there was a traveling disturbance. You're just sitting there, all of a sudden you're like, whoa! Okay? Disturbed. Okay? And that sort of carries energy. It's not, but you get the idea. That make sense? Okay? Traveling disturbance through medium that carries energy. Wave. Okay? All right, so parts of a wave. So an amplitude is, okay, so let's pretend you had a still pond and you threw a rock in it. Okay? The amplitude would be the distance from the still pond, the undisturbed medium, or the depth of the wave. Okay? The height or the depth. Okay? The distance from undisturbed medium. Good with that. Okay, the units, it's the distance, so we're measuring meters. Wavelength. You studied this in chemistry. It's the distance or the length of one complete cycle. Length of one complete cycle. The variable is lambda. It's an upside down inverted y. And the unit, it is a length, so we measure that in meters as well. So that could be here. That could also be here. This is the length of one complete cycle. Good with that. So these are all distance based. Okay. Take a shot at this one. Got your neighbor?
I think I see is the amp, but none of those are. But not. Yeah, BD. No,
Is it like or I said it's not. It's IC and A.
what?
Well, it's A and then IC or
Correct answer is E. None of them. Okay. Your wavelength could be AE, IF. No. Sorry. AE, BF, or CG wavelength. Your amplitude could be HI or it could be IC. Okay? Good? Which part is the huh? Wavelength or amplitude? A to C is not the amplitude. E.
There was that option. You're so mean.
that was like the one. That's the first. Wait, that's like the first time. Okay, it's one of the few times. It's in single digits where it's actually.
Okay. So that was all distance based. This is time based. Okay. We've talked about period before. The variable for period is a capital T. This is the time for one complete cycle. Okay. The unit for that is seconds. You could think about this as seconds per cycle. How long it takes to do one complete cycle. Okay. Nope. So, frequency. This is how many cycles in 1 second. Okay. The variable for frequency is a lowercase f. The unit is cycles per second, which is a hertz like the rental car company. Symbol for that is HZ. And the equation for frequency is 1 over the period. It's the inverse of the period. Okay? This is your cycles per second. You might have heard this as rotations per minute, RPM. Okay? That's a unit of frequency. Okay? So, watch the unit. Do you see how they're inverse of each other? Okay. So you'll have an you'll have a question like this one on the test and on the final exam. Okay. My recommendation would be to look at the units. Have a conversation.
Should be it.
It's one cycle.
It's seconds over cycle. It's about seconds over the cycle.
Because it also your unit
And
is
so
second.
we put 2 over A against 1
Oh wait, which is the 0 just 2? What is the period? Is it not just 2?
No, it's A. Okay, so it's
No,
seconds over cycle. So 2 over A.
Wait, but that would S over C.
Correct answer is?
Yeah, that's 8 times.
Got one vote for A? Correct answer is A. You're doing seconds over cycles. Okay? So the frequency would be what? Frequency would be 4, the inverse of that, cycles for every 1 second. Okay? So just as a, make sure we got this on lockdown. Tell your neighbor.
The one frequency.
Correct answer is A. You want cycles over seconds for frequency. So the period would be what? Would be seconds over cycles. Okay? You'll have a question just like that on the test and on the final. Please don't miss that. Pay attention to the units. Okay? All right. Before you took physics, what was the equation for speed? Speed is equal to distance over time. Okay? Good with that? Specifically applied to a wave, the distance, we're going to use wavelength over the time, we're going to use period. Good? Okay? Now, we know that frequency is equal to the inverse of the period, so we can also say frequency times wavelength is equal to the speed. Okay? All three of those are valid for finding the speed of a wave. Okay? You actually used this last year in chemistry already. When you remember this equation, using this equation for light, different colors of light, different wavelengths, different frequencies of light. Okay? This is the speed of a light wave. So it's this equation, just a very specific example. You all right with that? Okay. Okay.
You don't even know.
Neighbor?
As it is. You don't know. There's distance over time.
Correct answer is? You guys talk to your neighbor, right?
No.
Okay, correct answer is B. Okay? So we're doing wavelength over the period. Notice the amplitude did not come into play there. Distractor. Good with that? Okay? You might need a calculator on this one.
What's coming up Friday? What comes out Friday? You know what I'm doing
Already got it wrong. Actual Minecraft. Wait. Not so. Movie with Jack Black. It's kilometers. Yeah.
Wait, I got it wrong.
Give you a hint. Correct answer is E.
It's E. I got it.
Tell your neighbor what the answer should be.
1450. Yeah, it's
I got that point.
Say it.
Oh.
Tell them how you got it.
Oh wait.
Frequency of
7,200
2000
times 2,000.
times 0.7.
And then I just
You have your wavelength and your frequency. Alright, 6. Just have frequency.
Correct answer is 1,450. You could have gotten that 3 different ways. You could have done wavelength divided by the period. You could have done wavelength times the frequency. Or you could have done distance, convert that to meters, divided by the time. One of those 3 give you 1,450. Okay? Good? All right. Types of waves. Okay, the first type is a transverse wave. Okay? Which way is this wave traveling?
Left.
If you were a surfer, yes? Okay, it's going to the right. Now, transverse wave is described as A wave in which the particles oscillate. That's just a fancy word for goes back and forth. Goes back and forth. Oscillate perpendicular to the way the wave travels. Okay? Perpendicular to the way the wave travels. Okay? Pick a dot on okay? Notice how the dot is just going up and down. It's oscillating perpendicular to the way the wave is traveling.
But it looks like
It's not.
it's weird.
It is an illusion. But it's only going up and down as the wave goes that way. Perpendicular to the way the wave travels. Transverse wave. Good? Okay. So the second type is a longitudinal wave. Okay? This is a wave in which the particles oscillate. Not perpendicular, but parallel. Okay? Which way is the wave traveling? It's going to the right. You're like doing like a drone shot of the ocean. Okay? But look at an individual point.
Undertow.
Just oscillating back and forth as the wave travels. Good with that? Okay. Longitudinal wave.
In a longitudinal wave, the disturbance that makes up the wave is along the direction in which the wave travels. Longitudinal waves are also referred to as compression waves.
Okay? Now, here's some vocab for you. So these parts here are known as compression. That's not really brain busting. Okay? So compression, those points are called compression. Okay? The spread apart parts, this is known as rarefaction. Okay? Good with that? Rarefaction. Now, to draw longitudinal waves is kind of a pain. And so a lot of times what we'll do is we will draw longitudinal as a pressure graph. And so what this is, your undisturbed medium would be normal pressure. And then up here, this would be high pressure. And your rarefaction, this would be low pressure. So it's just oscillating between high pressure, low pressure, high pressure, low pressure, high pressure, low pressure. Good with that? And last one, this is just for funsies. Wait for it. No, where we're going here.
like the sound better. We can't really. I can. If you can travel faster than light, every time you want to power, I don't even. I can travel faster than light.
Yeah.
I'm like, no, you can see faster. Jesus Christ, it's so fast. We're supposed to go first.
So indubitably,
Yeah.
You can go just as.
Okay, so a water wave. Okay, think about watching like a buoy or a seagull on the mountain. Okay, so or on not mountain. So here you got longitudinal, transverse, ocean wave. It's actually a combination of the two. Okay? If you think about watching something like a piece of driftwood, something, even if like Lake Michigan, doesn't matter, it's going in a circle. So it's doing transverse and longitudinal at the same time. Okay? If you've ever swam in the ocean, like doing like snorkeling or something, if you're near the surface, it's like, whoa, whoa. But as you get deeper, it isn't as influential. For that. Okay, there you go. Got a pre-quiz due tomorrow.